Hey guys, it's Miss Johnson and I'm here to bring you our first part of Unit 2 Notes 3, which is when we're starting to solve systems algebraically. Today we're going to learn how to solve systems using elimination. So far we've solved systems using graphing, both equations and inequalities, using graphing and finding the point where they intersect on a graph. And now we're going to solve them algebraically by using elimination. So here are some points about solving systems using elimination. The first one is we cannot solve two equations with two variables. It is not possible. We have to somehow manipulate those equations and change how they look because we can't solve them. If we have an equation with two variables in it, we cannot get one variable's value without having the other variable go away. So we have to make one equation with one variable. Somehow we're going to manipulate these two equations so that one of the variables goes away. That's what we're looking at today. So in this case, we're combining the equations so that one variable drops out. Okay, so that's what happens when we're trying to solve systems of equations algebraically. We need to take those two equations and manipulate them somehow so that we have only one variable left. So let's take a look at number 1. In number 1, what I notice is the system I have is x plus 2y is equal to 10, and negative x minus y is equal to negative 6. So I can take a look. The first thing that I notice is that I have my x's, my y's, my equal signs, and my constants all lined up. These are both in standard form. Both of these equations are in standard form, which is helpful for me because what I can do with these is I can take them and combine them. If I draw a line underneath and add them together, it's probably kind of hard to see the yellow. There we go. I'm going to take these two equations and I'm going to add them together. And what happens is a 1 plus a negative 1 makes these two x's go away. And I'm left with 0x. Then I have 2y minus y. Well, 2 minus 1 is 1. So that's plus 1y. And then 10 minus 6 is 4, or 10 plus negative 6, if you want to think of it that way. So look at this equation that I created by combining the two together. The good thing here is that 0x carries no weight. This thing right here, 0x is still 0. It's nothing. It's gone. We made it go away. We eliminated the x variable. So I'm left with just 1y is equal to 4. And you can think of that as dividing by 1, but we know dividing by 1 doesn't change our answer. So I have y equals 4. Now I've got one of the values. Now that you have one of the values, you can take it and plug it into either original equation. I'll just pick the top one. X plus 2 times 4 is equal to 10, and solve it from there. So x plus 8 equals 10. Subtract your 8, and x equals 2. So when I write this out as a solution, my solution is a point. Just like on when we were graphing them, the solution was a point on the line. This is a point as well, so we need to write it as x comma y. So 2 comma 4, that is the solution to my system. So let's take a look at number 2. In number 2, again, I notice that x terms, y terms, equal signs, constants are all lined up. So I'm going to go ahead and add these together. I'm going to combine them and see what happens. So I have 2x minus 3x, and 2 minus 3, when I'm adding those coefficients together, 2 minus 3 is negative 1. And by the way, the reason I can add those coefficients together is because they're both x variables. They're like terms. All I'm doing here is combining my like terms. Then the y minus y, 1 minus 1 is 0, so that's 0y. 4 minus 8 is negative 4, or 4 plus negative 8, whichever way you think of it. So that 0y, there it is, carries no weight. It's gone. I can get rid of it. I don't need it anymore. So I have negative 1x is equal to negative 4. I need to divide by negative 1 here so that my x is alone, and I'm left with positive 4. Then I take that positive 4 and I plug it into either one of my originals. It doesn't matter which one you pick because it's a solution to both equations, so it has to work in both. So if I plug it into the top one, I have 2 times 4 plus y is equal to 4. So I have 8 plus y equals 4. 8, that's an 8, sorry. And then subtract your 8. So I have y equals negative 4, and my solution is 4 comma negative 4. All right, there we are. Now notice on the left that when I combined them, the x variable dropped out, and notice on the right here when I combined them, the y variable dropped out. It does not matter which one you start with. It doesn't matter which variable you're going to get rid of first. You get rid of the one that's most convenient, and then go from there, because eventually you have to solve them both. If you get y first and then x, no big deal, because you have to get them both anyways. So, all right, so take a look at number 3. I notice that I have x's, y's, equal signs, constants all lined up. So they're both in standard form, so I can combine them together. When I combine these, negative 2x and positive 2x, those are going to go away. Those are going to be the 0x that drop out. Then I have 3y plus 2y, which is 5y. And negative 11 plus 6 is negative 5. If I divide both sides by 5, I get to y equals negative 1. And then I plug in the y value into one of my equations. I'm just going to pick the bottom one because I feel like it looks friendlier. So 2x plus 2 times negative 1 is equal to 6. That 2 times negative 1 is negative 2. So 2x minus 2 is equal to 6. Add your 2 to both sides. 2x equals 8. And I end up with x equals 4 after I divide by 2 there. So I have a solution of 4 comma negative 1. Okay, let's take a look at number 4. So in number 4, again, x's, y's, equal signs, constants, they're all lined up. I know I'm in standard form, so I'm going to take those two and I'm going to add them together. When I take them and add them together, I have 1x plus 7x, which gives me 8x. I have negative 1y and positive 1y, which goes away. And it's all equal to 9 plus 7, which is 16. 8x equals 16, divide by the 8, and you're left with x equals 2. Then I take it and plug it back in. I'll just pick the top one. Doesn't matter which one you pick. 2 minus y is equal to 9. Subtract the 2. Be careful here. There's a negative in front of the y, so I have to keep that. So I have negative y is equal to positive 7, and divide by that negative 1 to make the negative go away. So y equals negative 7. So 2 negative 7 is your solution there. Let's take a look at number 5. In number 5, I have x minus y equals 9, and negative 7x minus y is equal to negative 7. So again, x's, y's, constants, equal signs, all lined up, standard form, add them together. So now take a look at what happens when we add these two together. When I add these two together, I have 1 minus 7, which is negative 6x. Then I have negative 1 and negative 1. That's a negative 2y, not 0. Then I have 9 minus 7, which is 2. Okay, here's a problem. I combined these equations, and the y term didn't drop out like I thought it would. And the x term certainly didn't drop out because they're not even the same number. So I need to go back to the drawing board. I need to look back at what I have up here. So here's your original system. X minus y is equal to 9, negative 7x minus y is equal to negative 7. Now what I notice is that I want these two things to be opposites. I need one to be negative and one to be positive. If you look back at numbers 1 through 4, this was a negative 2x, that was a positive 2x. This was a negative 1y, that was a positive 1y. This one was positive 1, negative 1. This one was positive 1, negative 1. One is positive, one is negative of the same number. So that means I need to do a little bit of work here. I need to do a little manipulating. I'm going to take this bottom equation and I'm going to multiply it by negative 1. When I do that, the top equation stays the same. X minus y equals 9. But now the bottom equation, this negative 1 is going to go all throughout, even across the equal sign. And that leaves me with positive 7x plus y is equal to positive 7. And then I have a negative 1y and a positive 1y, and when I add them up, they'll cancel out. So take note of that. Take note of the fact that those y's didn't start as opposites. They need to be opposite. So if that's a note to write down for you, you need opposite coefficients. Okay. Now I'm ready to add those together. And when I add those together, I end up with 8x is equal to 16. And if you'll look, now we're back at the same system that we had in number 4. So now that I've manipulated that second equation, I've multiplied it by the same coefficient. The negative 1 went all the way through all 3 parts. Now I can solve for the rest. I get x equals 2. I plug it back in. 2 minus y is equal to 9. Subtract your 2. That's negative y equals 7. Y equals negative 7. So your solution there is 2, negative 7, just like it was in number 4. Because again, once I manipulated that system, it ended up being the same system that I had in number 4. So now let's take a look at number 6. X's, y's, equal signs, constants, all lined up, so I'm good there. Now I look at my coefficients. I see a negative 4 and a negative 4. That's helpful, but not quite there. So I need to multiply one of these equations by negative 1. I'm just going to pick the top one. It doesn't matter which one you pick. You can pick either equation. So if I multiply all the way across, that gives me 4x minus 2y equals negative 8. The bottom equation is going to stay the same. Negative 4x plus 3y is equal to 10. And now I'm ready to add them. Because now when I add them, just like over here, y minus y goes away. 4x minus 4x goes away. So then I'm left with negative 2 plus 3, which is 1y, and negative 8 plus 10, which is 2. So that's just a y value of 2. I plug it back in to get the x value. So I'm going to just pick the top one. I go back to the originals whenever I do this. It doesn't really matter. You could use one of the manipulated equations if you want, but I just always go back up to the top. So negative 4x plus 2 times 2 is equal to 8. That's negative 4x plus 8, or sorry, hello, 4. 2 times 2 is 4. Plus 4 is equal to 8. And then subtract your 4. That's negative 4x is equal to 4, and divide by negative 4, and you get negative 1. So I have a solution of negative 1 comma positive 2. There's my xy. Okay, we're going to take a look at one more video, and then we're going to take, or one more question, and then we're going to take a pause for this video and pick up with the second half. So flip your page and let's look at number 7 at the top of the back page. The sum of two numbers is 12. The difference of the same two numbers is negative 4. Find the numbers. Now, you don't have a system here. You have some words that you have to convert into a system. If you think back to Unit 1, I believe it was Lesson 1 or maybe Lesson 2, we talked about translating words into symbols. How do I turn words that are written for me into mathematical symbols? So I'm going to go through these sentences and I'm going to figure out what it is they're trying to ask me. First of all, whenever I have word problems, I know I'm trying to identify my variables. I'm just going to use x and y as my two numbers, if you will. They're asking you to find two numbers, so that's what I'm going to use. So then when I go back to the beginning, I know that sum tells me I'm adding. Two numbers means I'm looking at x and y, and is tells me equals. So if I wrote that out as an equation, I'd have x plus y equals 12. Okay, so let's take a look at the next one. Then I have the difference. Difference tells me subtraction of the same two numbers, x and y. Still looking at is equals negative 4. So my other one looks like x minus y is equal to negative 4. And check it out, there's my system. That's what I have to solve, okay? I already noticed that I have x's, y's, equal signs, constants all lined up. As long as that is true, then you're ready to solve this using elimination. So I can add these together. When I add them together, my 1y minus 1y drops out, so that goes away, which is good. 1x plus 1x is 2x. And then 12 minus 4 is 8. Divide by the 2, and you get x equals 4. The next variable, then I have to plug it back in and solve. So then I'm going to go to the top equation and just plug it back in. 4 plus y is equal to 12. Subtract your 4, and you get y equals 8. So your two numbers are 4 and 8. Okay. All right, so that's going to conclude our first half of Unit 2, Notes 3. Thanks for tuning in. Don't forget to take a look at the second half of the video and show your notes sheet to Miss Johnson, and have a good day.